Hello and welcome back to Business Statistics. You've made it. This is the final chapter. We're looking at chapter 15 today, and this is involving chi-square testing. So for scale independent and dependent variables, we use correlation and regression. Now for nominal independent variables and scale dependent, we have used z-test, t-test, and ANOVA testing. But we'll need to use non-parametric testing when the dependent variable is nominal. So when the sample size is small and the population is not normal, we will use chi-square tests. So limitations are we won't be using as much confidence levels and we'll get type 2 errors, which we looked at in chapter 10. For the chi-square test, we use hypothesis testing steps similar to what we have used before. So step 1 is to identify and state the hypothesis. Step 2, characterize the comparison distributions. Step 3, determine the critical values. And step 4, calculate the test and make a decision. So the formula for chi-square is the sum of the observations, O, minus the expected value, E, squared divided by the expected value. So in an example where we're trying to calculate the chi-square value on 52 observations performed and 28 expected frequencies, we simply take 52 minus 28 squared and divide that by 52. So hopefully not too complicated. Now, there is a good YouTube on chi-square testing called Chi-Square Test by Jeff Davis that you might want to take a look at in more detail to get an idea of how to calculate this. Now, there is some Excel examples that I'm going to share with you to hopefully help you calculate chi-square test for the homework. So let's take a look. Now here we have a chi-square example where we are taking a product that males and females have observed, and the results came out of males and females deciding whether they would look at buying this product, not at all, somewhat, and very. Now, when we find these values, we put them in a table, and basically we want to first total each column and then total each row. Once we have those totals, we want to calculate the percentages of each of the answers. So the way we would do this is simply take this value right here for not at all and divide it by the total 124. So we're going to come up with 0.40 here. We will do the same thing here, so we would take our cell E4, divide that by the total E6, and come up with 0.28, and so on. So then we need to come up with a table of expected values. And here we're going to take, again, the same answers. And the way we're going to calculate our expected value is we're going to take this, this total right here, 65, for our males. And then we're going to multiply it by the percentage of not at all. So in this case, it's 0.40. So that's how we come up with a 26 right here. Similarly, when we do the females not at all, we're going to take this total here and multiply it by that percentage and come up with 23.79. We're going to go down the columns and do the same thing. So here it would be 65 times 0.28 and so on. Now, in order to do our chi-test, it's fairly simple now that we have all the data together. So there is a formula in Excel called CHITEST that we can easily calculate by writing equals chi-test, and then we're going to open parentheses, select the data on our observed column, comma, and then select the data on our expected column. In this case, the result for that is 0.359, which is larger than 0.05, and therefore there's not enough evidence that the male and female opinions are much different. Now the book then goes on to Kramer's V theorem that shows us how to calculate the size by taking the square root of the variable x squared and dividing by the number of observations, multiply by degrees of freedom. So there is a good YouTube on this that shows you more detail on how to do this, called Excel's Kramer's V by StickPed, that you might want to take a look at. And in the meantime, I will show you an example of how to calculate it. So again, we're looking at the male and female relationships, and how many of those males are either married, divorced, separated, or never married, or widow, and the same with the females. Again, we do the same thing. We total our columns and total our rows, and then find the percentage for each of the values or options. Then we do an expected table again, similar to how we did in the previous example for chi-square. And what we're trying to find again is those values here based on the percentage for each. So for married males, we're just going to take that total 873 and multiply it by 0.5 for married, and so on, and fill out the table. We're then going to do our chi-test, where we do equals CHI-TEST, and then basically select this data right here, and then comma this data for expected values right here. And our total comes out to 16.98. So when we do our Kramer's V, what we're going to plug in the formula is equals the square root, which we do it in Excel by writing equals SQRT. Open parentheses, we're going to take that L17, which is our chi-test square value, and then we're going to divide it by L8, which is going to be our total for the observations. So our total observations for both female and male were 1941. We're going to take that value, multiply it by the number of N. So in this case, we had males and females, so N is 2 minus 1, and come up with a value 0.093, which is going to be our Kramer's V value for this example. We can then graph the data easy enough. We just select the data right here that we're trying to graph, and simply go to Insert. We want to go to the options of the graphs that we want to take a look at. I chose a bar graph, and then basically come up with a graph to illustrate what the differences are between males and females that were married, divorced, separated, never married, or widowed. As you can see, the females in each of these cases turned out to be slightly higher, and most likely or not, the widow rate is more than doubled. That's possibly because females tend to live longer than males, and that might have driven the results being higher for each of the instances versus the males. So again, hopefully this is useful to you when doing your homework. And this is the last of the chapters, so hope you enjoyed them and got some use out of them, and hope to see you next time. Have a good one.